Hey chemistry peeps, Jess McCartney here. So today we're going to start talking about rate of reaction. But first of all, we're going to start talking about the collision theory. So pool can be a very visual way on showing how the collision theory works on a molecular level. So when you are playing pool, you need to use the white ball to hit the coloured balls, and based on how you hit them with the amount of speed and in the correct way would depend on whether they go in the pocket. So collision theory is essentially that, and we're going to talk about that today. So we are going to be looking at the factors affecting the rate of reaction. The study design dot points that we're going to cover today is the factors affecting frequency and success of reactant particle collisions and the rate of chemical reaction in open and closed systems. And this is going to be looking at the effect of temperature, surface area, concentration, and gas pressure. So for a chemical reaction to proceed, certain things need to occur. So if all three things don't occur, then the reaction will not proceed to its products. So this is known as the collision theory. So when we're looking at the three things, they are that their reactants must collide. So if they do not collide, they will not react. So that's the first thing that must occur. Reactants must collide with sufficient kinetic energy. So if you remember when we were looking at the energy profiles, that the activation energy is what needs to be overcome for the reaction to proceed. So this is known as the sufficient energy for the reaction. So if it doesn't collide with enough energy to overcome that activation energy, it will not proceed to the products. And then the last thing is that reactants must collide in the correct orientation. So you can see in this diagram here that if they collide not the way that they're supposed to, so like this is showing one vertical and one horizontal, then no reaction will occur. So for them to proceed, that in this particular reaction, the particles must collide when they're both vertical, and therefore it would proceed as long as there is enough energy. So the three things must occur all at the same time for the reactants to produce products. So chemical reactions are occurring all around us, and some we would notice and some that we wouldn't. So when we're looking at gases, for example, a lot of the times we would not notice these reactions proceeding. Now, some reactions can be very, very slow, and this is sometimes helpful, but sometimes it's also not helpful. We want to be able to get products as quick as possible, especially if we're needing to use those products. So there are certain things that we can do as scientists to increase the rate of a chemical reaction. Now, these things are looking at the surface area of the solid reactants, looking at the concentration of the reactants in solution, looking at the gas pressure, the temperature of the actual reaction, and the presence of a catalyst. So the things that we are going to discuss today is the ones 1 to 4, and we will be looking at a catalyst in the next lesson. So when we are looking at temperature in terms of the rate of reaction, as we increase the temperature, this will increase the number of collisions that's occurring in the reactions, and that's because the particles are moving faster. So the likelihood of them going to come into contact with each other increases. Now, one thing that temperature does that all the other things don't is it actually increases the energy behind those particles. So this increases the kinetic energy. So this temperature is the only effect that also increases the percentage of successful collisions. Now you can see with this graph here how it's occurring. So at a lower temperature, we have the product concentration. You can see that there's a small increase and then it plateaus off. But when you have a higher temperature, it increases quite dramatically and then it plateaus off. So you can see that there is a greater percentage of successful collisions, and temperature is the only thing that does that. So the second effect that we're going to look at is surface area. So when you are increasing the surface area of a reactant, you are changing the amount of reactant that can come in contact with the other reactant. So if you're looking at this picture here, we have a solid mass, then it's broken up into 2 bigger masses, and then it's broken up into 8 smaller masses. Now, if you are reacting these masses, the ones that are smaller will come in contact with the other reactant more frequently. So therefore, as you increase the surface area, you increase the frequency of collisions. Now, increasing the surface area does not increase the percentage of successful collisions. This will still be the same, but it is increasing the amount of collisions that is occurring, but the energy supplied in those particles is exactly the same no matter what the surface area is. So next we're going to look at gas pressure and how that affects the reaction rate. So when you're thinking of gas pressure, the easiest way to look at is when you have gases in a plunger. So you can see that in the first plunger here that the gases are quite spread apart. So there's lots of space between it. Now, if there's space between it, that means that them coming into collision would be less likely. Now, as you push the plunger down, as you can see in this second diagram here, you can see that the space decreases. Now, as the space decreases, the likelihood of them coming into contact would increase. So therefore, this would increase the amount of collisions that are occurring. Now, this does not change the energy that's behind these particles, okay? So the amount of successful collisions doesn't change, but the amount of collisions that's occurring does increase. So therefore, this would increase the reaction rate by increasing the frequency of collisions, but doesn't increase the percentage of successful collisions. So when we're looking at concentration, we're looking at the amount of solute that's dissolved in the solvent. So looking at these pictures here, you can see that the increased concentration is occurring. We have more of this solute dissolved in the solvent. Now, if there's more solute, that means that there's more particles to collide. So as there is more particles collide, the amount of product that will be produced will increase. So it increases the frequency of collisions. Now, the energy is not changing, so therefore the percentage of successful collisions doesn't change due to the energy. So let's have a go at an example. There have been many explosions in underground coal mines due to the presence of coal dust. So that's the first thing that you need to have a look at, is that we have dust particles here. Explain the observation in terms of collision theory. So we need to have a think about how the coal dust affects the amount of collisions that's occurring and therefore the explosions that's occurring in this underground mine. So the sample answer for this particular question is that explosions are very fast reactions. So what is occurring for these very fast reactions to happen? So the large surface area of the coal dust allows an increase of frequency of collisions. So we're linking it back to the collision theory, and that's really important because that's what the question says. So the coal dust is an increase of surface area. How does this affect the rate of reaction in terms of the collision theory? It increases the frequency of collisions. And this increases the rate of reaction so much that explosions can occur. So in terms of the mark allocation, the first thing you need to do is identify how an increase of surface area affects the rate of reaction using the collision theory. So increasing the frequency of collisions. That's one mark. And the second part is explain how the surface area would increase the number of explosions. So identifying that the increase of collisions would increase the rate of reaction, which therefore would make those explosions. And that's the second mark. So this table is really good to bring everything that we've learnt today together. It just makes it nice and neat in terms of the collision theory and how each of these affects the rate of reaction. So we have the factor, which is the temperature. Now, if we are increasing the temperature, it increases the proportion of particles with sufficient energy. Now, that is the only effect that does that, and it increases the frequency of collisions. Therefore, it increases the rate of reaction. All the other ones, so surface area, gas pressure, and concentration, all increase the frequency of collisions. It doesn't affect the kinetic energy, but this will all increase the rate of reaction. So in summary, the three things that must occur for collision theory is the reactants must collide, which is this one here. They must collide in the correct orientation, so whatever that would be for that particular reaction. So the correct orientation must occur, and they must have sufficient energy to overcome the activation energy for that particular reaction. There are certain things that we can do to affect the rate of reaction. So we can increase the surface area of solid reactants. We can increase the concentration of reactants in solution. We can increase the pressure by decreasing the volume of the reaction, increase the temperature. And the last thing is the presence of a catalyst, which we will talk about in the next lesson. So what's coming up next is catalysts. I will see you then. Bye-bye.